So, hi Nathan. Very good morning, buddy.
Yeah, I'm here.
Yeah. So, Nathan, today we'll discuss regarding what sir have sent it to me. So I have the content that is related to factoring, right? You can see on the screen. No. Let
Yeah, I can
me
see the
share this
screen, but
tab.
you gotta give me
Yeah.
some time.
So this is the one which we have. So we have something called MAXX approach, and
In man approach.
yeah, and then the main approach, right? So basically this is nothing but related to factoring. So for example, if I have a one equation, for example, I'll take it for the one which is given this word file. So x square plus 15 x plus 36. So x square plus 15x plus 36, right? So yeah, sorry, I don't know why it's not writing properly. Yeah, equal to 0. So whenever your coefficient of x square is 1, right? It's 1 as of now, right? So whenever it is 1, you can use the MAXX approach. And whenever it's not 1, for example, if I take another equation which we have here, um, that is 5x square minus 14x, 5x square minus 14x plus 8 equal to 0. So here we don't have the coefficient of x square as 1, right? So here we can use the
Yeah.
main approach, the main approach. So basically whatever it is, how we can factorize this, let's see. So always remember we have to compare this with the standard quadratic equation, which is this, right? Ax square plus bx plus c equal to 0. Is that right, Nathan?
Yeah, it's right.
Yeah. So what we do, always remember, we have to find out the product of the coefficient of x square and the constant term. So that is a times c. Okay. So here the coefficient of x square is a and the constant term is c. So you have to find the product of that, and you have to find this addition. You have to find the sum, which is basically equal to the coefficient of x, which is b. So you have to find out the product of the coefficient of x square and c, I mean the constant term, and the sum, which is be the coefficient of x, the middle term. So if we discuss regarding the first equation, which is here, 1x square plus 15x, same method applies for both the equations, whether the coefficient of x square is 1 or anything else. You have to use the same approach. Is that okay,
All
Nathan?
right.
So if we see here, I have to find the product. I just told that first of all, yeah, before writing all these things, what you need to remember is let's compare it with the standard quadratic equation. So we have ax square plus bx plus c equal to 0, right? Now let's compare. So what is your a
All
here?
right.
1, your b is 15, and c is 36. Agree or not?
Yeah.
So let's find out the product. Product will always be a times c, as we just discussed. So a is 1 here, and your constant term is 36. So this will gonna
All
become
right.
36. Okay. And what is the sum? Sum will always be equal to the, or addition will always be equal to the coefficient of x, the middle term, which is b, and the b in this case is 15, right?
All
Now
right.
you have to
So wait,
figure
when
it
should I
out.
use max and when I should use man?
Sorry.
When should I use max and when should I use man?
What I feel is, for me, both are same. I don't treat both
Or
as
same?
different.
They're same,
Yeah,
but
it's
I
the
thought you have
same.
to use like.
The treatment is same, Nathan. Nothing to differentiate it. That's the reason I thought we'll follow the same approach. So what we have to do is we have to find the product and the addition. Both will be the same. It's nothing a different approach will follow for these max and the man approach. Okay. So a equal to 15. Now you have to figure it out. Two such numbers, Nathan. which when multiplied you get 36, and when you add you get 15. Do you have such numbers? That is something always be a challenging. So what we do, we always no, factorize the product what we have got to get an idea. So we have 18. Okay, if we do it further, we get a 9. We go further, you get a 3 and 3. Now try it, make some combinations, like 2 into 2 is 4, 3 into 3 is 9. So 4 into 9 is 36, but 4 plus 9 will be just 13. We need 15. So use another combination. Why not 2 into 2 into 3, which is 12, and you have 3. See, that's correct. 12 times 3 is 36, right? Right?
Yeah.
And 12 plus 3 is 15.
All
12
right.
plus 3 equal to 15. Why it's not responding properly. Yeah, 12 plus 3 equal to 15. So 12 and 3 are such numbers, Nathan, which will gonna multiply to get 36, and when you add them you get 15. We always have to find two such numbers which multiply and equal to p, and when you add you should get equal to a. So now this become easier. So what we will do, the equation, I'll reduce the size so that you can see it properly. Yeah, now the r equation was x square plus 15x plus 36 equal to 0, right? Now what we
Mm-hmm.
will do, we will write like this, Nathan. 15x, we will write it as 12x plus 3x. Okay, so 12x plus 3x is 15x only, right? Plus 36 equal to 0,
Mm-hmm.
right? No doubts, right? We are all good, no? All good,
Yeah,
right?
no doubts.
Okay. Now, let's come back. Mm, yes. So we'll take it x common. Always make no, take commons from the first two terms, and the common from the last two terms. From the first two terms, what you can take common, Nathan? I think x, right? So x will be common, and x
Mm-hmm.
plus 12 will be left over, right? From the last two, you can take 3 common, because 36 can be written as 12 times 3, and again you left with x plus 12. Always remember that you should, or you will be left with something similar, x plus 12, x plus 12. Two brackets should be the same. Now if I write it over here, the top, you can combine the ones which are outside the brackets, and the one which came twice, you can write it once, write them at once, don't write twice. So x plus 12, and the ones which are outside the bracket, club them to form another bracket. Sorry, 1 second. X plus 3 equal to 0. So these are your factors, Nathan. So this is your basically the MAXX approach, where your x was equal, where the coefficient of x square was 1, isn't it?
Yep.
So this is how, Nathan, you can differentiate between MAXX approach and MANN approach. But yeah, whatever it is, the treatment, the way of doing the questions is always be the same. Now I will take another one, Nathan, the one which was there where the coefficient of x square wasn't 1. Let's see that,
All
which
right.
was, yeah, the 5x square minus 14x plus 8, right? Let's do that. Let me take a different color. So 5x square, why is not writing properly? 1 second. 5x square minus 5x square minus 14x. Yeah, I'm just trying to write it properly. Yeah, plus 8 equal to 0. So here the coefficient of x square is not 1, right? But yeah, as I told, We don't have to see all these things. We have to compare it with the standard quadratic equation, which is ax square plus bx plus c equal to 0, right? Now,
All right.
can you tell me what is a here by comparing this with the
A
standard?
would equal
Hmm. Yes.
1.
No.
Wait, no, wait, no, that's 5. Or A equals
Yes.
5.
Very good. So a is 5. And what is the b equal to?
14.
Very good. B equal to 14. 1 second. Yes. And what is c equal to?
C is equal to 0.
No, no. Compare.
A 1? Oh, 8.
8, right? C is nothing but the constant term. Now, as we discussed in the previous question, Nathan, we always have to find the product. And the
All
product will
right.
always be A times C, right?
Mm-hmm.
And what is A times C here will be? 5 times 8, isn't it?
Yep.
This is my 5, okay? So 5 times 8, which will be 40. Now, we have to find the addition, or you can just say sum, and that will always be equal to the coefficient of your x, the b, and the b here is 14, right? As we discussed, Nathan, last question, we have to find out two such numbers which when multiplied we get answer as 40, and when we add them when we add them we should get the answer as 14. Do you have Can you think of something, two such numbers, Nathan? Or do you have such numbers which when
That
multiplied
multiply
you get
into
40 and add you get 14?
4 and 10.
Super buddy. Yes, that's correct. So those numbers are 4 and 10. Well done. So now what we'll do? We will factorize it. Let me take it a little up. So 5x square minus 14x plus 8, right? Okay. 5x square, 5x square minus 14x plus 8 equal to 0. Yeah, that's the question. So what we'll do? We'll split the middle term. So we can write it as minus 10x, right? And minus 4x
Mm-hmm.
plus 8 equal to 0. Now, if you see now, Nathan, even if you add them again, minus 10, minus 4, minus 14, see, it's the same. It's not different, right? These all are same only. It's just a different way of writing so that we can factorize it. Now, always remember, we have to take the common from the first two. And you have to take the common from the last two. Now, let's take the common. So, from 5xk minus 10x, what you can take common, Nathan?
From you can take 5.
5x taken common, right? Because x is also there. So you're left with x over here and you're left with minus 2 here, isn't it?
Mm-hmm.
From here, you can take minus 4 common, and then in that way, you're left with x minus 2 here. Make sense? Always remember, you should always get these things same, two brackets. Okay? If it is not coming same, means we are doing somewhere wrong. You have to check that. Now, the one which are coming twice, the bracket which I have underlined with the orange color, you have to write them once, and
Mm-hmm.
the ones which are outside the bracket, you have to combine them. So this becomes 5x minus 4 equal to 0. And these are your factors, buddy. Make sense?
Mm-hmm.
If you have to find the values of the x, just one more step. What will be that step? Just put them equal to 0. So put x minus 2 equal to 0. So you get x equal to 2. Yeah. And if you put
All right.
5x minus 4 equal to 0, then you get your x equal to 4 upon 5.
All right.
So these are your values of x, or you can say these are the x intercepts, because you have some questions where you need to find out all this. So yeah, it will be good. So what all we discussed till now is factorizing, the quadratic equations. We are not discussing, specific to max or the man approach, because both are the same. The way of solving is all same. What you need to do, write the equation, compare compare that with the standard quadratic equation, which is ax square plus bx plus c, right? And
Mm-hmm.
then what, you have to figure it out. You have to find the product of a and c terms, and you have to find the sum, which is equal to the coefficient of x, which is a b term, right? All good so far? And then you have to
Mm-hmm.
find out such two numbers.
Maybe-ish,
Yes,
potentially-ish,
that's good.
possibly-ish.
That's good, Nathan. So you have to find the two such numbers, which added up to get b, and multiply it to get what we have, the product a times c. After that, you have to write the middle term as the sum of those two numbers, and then find the factors from the first two terms and the last two terms, and then club it to get the factors. And if you put them equal to 0, you get the values of x. Yeah. Let's take
Mhm.
another question, Nathan, and then we'll see how to find the vertex and all. Okay. Uh, we have here 25x4 minus 49 y square. Yes. So 25 x raised to power 4 minus 49 y square. Okay. You have to factorize this. So very important, we should know some of the identities, Nathan. So here we have an identity called difference of the squares, which is a square minus b square. I hope you already know that a square minus b square is always equal to a plus b into a minus b. A minus b. All is good, right? The same here, Nathan. We have to see here what we need to do. You have to express this in something a square and b square form, right? You have to express that into
Yeah.
a square minus b square. So how we can do that? So if you see, 25 can be written as 5, right? And x square, x raised to power 4, you can write it like this, and then square it. One second, like this, yeah. Yes, minus 49 can be written as 7, right? And y square you can just write at y, and then raised to power 2, and then raised to power 2, right? See, if you open up the
Mm-hmm.
bracket, you still get the same thing. 5 square will be 25, x square raised to power 2 will be x raised to power 4, and same here, 7 raised to power 2 will be 49, and then y square, isn't it? Correct, no? Now use the
Mm.
identity. It says a square minus b square should be equal to a plus b times a minus b. So we can write this as, because this is your a, this is your b. Now you can write it as minus a plus b. So just add them. So 5x square, 5x square plus 7y. I don't know, there's a little lag. Plus 7y times 5x square minus 7y.
All
You
right.
understand? This is 7, okay? Yeah. Do you understand this, how we did it? Let me raise it and do it
Mhm.
properly. This is 7. Yeah. So that is factorizing with the help of identities. You have many other identities like a plus b raised to power 2, which is a square plus b square plus 2ab, right? Let me write it down. Yeah, you have many such identities, right? But yeah, these are the main ones. So a plus b raised to power 2, I think very popular one, right? We would have studied in even lower grades as well. So a plus b raised to power 2 is a square plus b square plus 2ab, right?
Mhm.
And another one what we have is a minus. So basically if I um, explain here only, so if it is a minus over here, it only come minus here, that's it, the same identity. So a minus b raised to power 2 is a square plus b square minus 2ab. And then we have even the cubic ones, so a plus b raised to power 3 and all those stuff. So as I go with your unit review package, which is so that only covers up the difference of squares and the things, the splitting the middle term, what we just discussed, right? Any doubts so far, Nathan? All good?
Not really.
Super buddy. Now I'll do one thing. I'll take one question. um, I'll paste it over here. 1 second. Which is from that unit review only. Yeah, I have it. Yeah, I'm pasting it here. Can you see?
I think.
Yeah. Yes. So a baseball is hit and its height is given by the equation. So it's a quadratic buddy, where h is the height in meters and t is the time in seconds. So they have asked you the questions. What is the maximum height of the ball? Okay. And when does the ball reaches its maximum height? Okay. And how long it is in the air?
Mhm.
So yeah. So there was a baseball, right? And yeah. So this is the equation. So h equal to minus 5t square, right? Plus 20t. So you have to find the maximum height, right? Very simple, buddy. Always remember the maximum height, if you have to find out, actually is the x coordinate of the vertex. Okay, that's the x coordinate of the vertex. Basically, it will be like this type of parabola, because whenever the coefficient of the x square term, or you can say when the coefficient of the square term is negative, right? That means it will be a downward parabola, isn't it? Because here is negative, no, Nathan. That's the reason the shape of the parabola will be like this. So maximum height will be at the vertex, right? The maximum height will be at the vertex.
All right.
So how to even how we can find out the vertex? We have questions like that to find the vertex. So the vertex x coordinate is always be find out with the formula. X coordinate will always be equal to minus b upon 2a, minus b upon 2a. So if you compare this with the standard quadratic equation, which is x square ax square plus bx plus c, where what is a here? Minus 5, right?
Yeah.
And what is the b? B is 20, right?
E.
Agree, Nathan?
I might, maybe,
No, compare
sort
it.
of.
No, compare it, right? So I have written here x, right? So what I can do, I can write it. I mean, it can be any variable. So it's not. I think my mistake. It also deleted that one. So what I was telling, you can take t here, not a problem. So a t square. I think then the comparing will be easy. Now, if you compare, it's very simple. A will be minus 5 and b will be 20. Now you can put this. You have to learn this formula, Nathan. The x coordinate of the vertex is minus b upon 2a. So minus b upon 2a means it will be minus of
Uh,
20, right? Divided by 2a. 2a means 2 times minus 5, right? Because your a is minus 5.
right.
So this become minus 20, and 2 times minus 5 is what? Minus 10. And that's how you get 2. So x coordinate of the vertex, x coordinate of the vertex, x coordinate of the vertex is 2, right? That means after 2 seconds, the ball will be at its maximum height, right? Correct, no? You understand this, right? Let me take it to the side little. What's the maximum height reached by here is, they have the told any units. Okay, sorry, this is the x coordinate, right? So yeah, x is, let me draw a line like this. If I have the coordinate plane, right? So I think this is your x coordinate, right? And this is your y coordinate. X, I think, is the distance they're talking about. So yeah, distance is over here, and I think time is over on the y-axis, or is the other way around. H is over here, right? So yeah. So, buddy, at units, they haven't told anything. Oh, h is in meters, right? Yeah, they have told that the unit of distance is in meters. That means 2 meter will be the height, maximum height it will have. Make sense? Are you getting it, Nathan? What are we doing? So
Yes, I get it.
what is the maximum height of the ball? What is the maximum height reached by the ball?
Maximum height would be uh
There's the x coordinate coming out to be, right. So I think if it is, now question is it which coordinate they are taking it? H is y, right? So I think distance is over here, buddy. Distance is over here. So this is the time. The x coordinate, they have taken the time here. Okay. So yeah, then the x coordinate is this. So what is they asking? Maximum height reached by the ball, right? Then we are right. Minus b upon 2a. Now when does the ball reach its maximum height? Just put t equal to 2 here. You'll come to know, right? Let's do it. Let me drag it a little up. So h will be, so what was the equation? Minus 5, right? So minus 5. Now put the t value, which is 2. Yes, it's a little laggy. Okay. So yeah, t2 square and plus 20 times 2. 1 second. Yeah, 20 times 2. You're just putting the value here. And this will be coming out to be minus 5. Yeah. And 2 square is 4, right? And here, what will you get? 20 times 2 is 40, right?
all right.
Yes. So minus 5 times 4 is minus 20. And here you get 40, which will come out to be 20.
All
1 second.
right.
20. Height is 20. So when does
Hmm.
the ball reach its maximum height? But I
The
think
20?
this was the 20 is the maximum height. 20 meters is the,
Yeah, so when does it reach
yeah,
maximum height? Wait,
yeah,
a
this is the,
ball?
and when did it reach the maximum height? After 2 seconds. Okay, this is the second. So when we have find the x coordinate, that's a second, because x coordinate is the time. So 2 seconds. So after 2 seconds, the ball have reached its maximum height, which is 20 meters. So how did we find the time? We use the x coordinate of the vertex formula, which is minus b upon 2a, which we got it as 2. And they have taken the x coordinate as the time. That means after 2 seconds, the baseball have reached its maximum height, right? And what was the maximum height after 2 seconds? We just plug in the value in the equation, and we got the h as 20. Basically, this is the y coordinate of the vertex, because we will just know after this question, we'll also do the vertex thing, how to find the vertex of the any quadratic equation or any parabola. So how we do? For x coordinate of the vertex, we use the formula minus b upon 2a. Once we get the value, we plug in that value in the equation to find the y coordinate of the vertex. So here x coordinate of the vertex in this question is giving us the time. At what time the ball have reached its maximum height, which is 2 seconds, right? And what was the maximum height? When we plug in that value in the equation, we got the answer as 20. That means 20 is the maximum height the baseball has gone. Now, the third question, if you see, Nathan, they're asking how long is it was in the air. Very simple, that is. So, if you see here, it took 2 seconds to reach here, right? So, 2 seconds to reach down as well. 2 seconds here, 1 second, 2 seconds here, 2 seconds here, total makes 4 seconds. So 4 seconds. The answer of the last question is it was there in the air for 4 seconds. Why? Because the maximum height it reaches 2 seconds, then it will come down, right? Another 2 seconds. So 2 plus 2 is 4. So it was there in the air for 4 seconds. Now let's take a question to find the vertex. I think that will help us. I'm just taking one question where we need to find out the vertex. 1 second. Yes, I have it here. So determine. I'm just taking to, yeah, I have the question ready now, and I'm just dragging it up and pasting it here. 1 second. Yes, this is what it is. 1 second. Yeah. So we have to find here the vertex of this equation, right? And just now we discussed, Nathan, that the vertex x coordinate will always be equal to minus b upon 2a, right? Please learn it and write it down. The x coordinate of the vertex is minus b upon 2a. But before that, you have to write what is a here. If you compare with the standard quadratic equation, which is ax square, yeah, ax square plus bx plus c equal to 0. Yes. Now, if what is your a here? If you compare it, it is 1. What's the b here? Minus 10. Make sense?
Yeah, it makes sense.
Yeah. And what is c equal to? 24. Yes. Now we have to plug in. So minus b minus of minus 10. See, don't confuse with the two negatives. The b value is minus 10. This minus is fixed. And then divide by 2a, which is 2 times a, which is 1. So this will come out to be plus 10. And here, because minus minus is plus, and 2 times 1 is 2. And 10 divided by 2 is 5. Yes, so x coordinate is 5. Fine. Now what we need to do, we just discussed, we have to plug in. We have to plug into the equation. Whatever the equation we have to find out the y coordinate. So y equal to, it was equation is x square minus 10x plus 24.
All right.
So what we need to do, we have to plug in the value 5. So
All right.
instead of x, just write 5. So 5 square. 1 second, I'm just writing down. Minus 10
I
times.
have a question. So max like makes is uh when the thing is not like when a is not 1.
Yeah, yeah, that's correct. Now if you put in the value here, you get 5 square as 25. And then minus 10 into 5 is your minus 50, right? And then plus 24. So what do we get? So minus 25 minus 50 is minus 25, and minus 25 plus 24 is basically minus 1.
All right.
So your coordinates of the vertex are 5 comma minus 1. This is how we do. Yeah. So what all
All
we did,
right.
let's summarize, Nathan. So we have the equation, any equation for that matter. Whenever you get it, compare it with the standard quadratic equation, which is ax square plus bx plus c equal to 0. Find out the values of a, b, and c. And then the x coordinate of the vertex will always be minus b upon 2a. And here, when we plug in the values of b and a, we got the x coordinate of the vertex as 5. Now, this x coordinate of the vertex we had put into the original equation what we have, that is xk minus 10x plus 24. I think I missed to put plus here, plus 24. And then when we when we plug in the values, we got the y coordinate as minus 1. So the what is the vertex coordinates here? 5 comma minus 1. Is that all good, Nathan? Any doubts so far?
Not really.
Not really, right? So all is good, right?
Mhm.
Very good. So rest of the concepts, Nathan, we'll discuss in the next class. So you have, and we'll also cover up the how to solve the other linear equations with the simultaneous linear equations with the substitution method, elimination method. We'll discuss in the next class. Okay. Thank you.